All right, we're going to be covering part of Chapter 11. I'm not going to necessarily follow along with what they do, but there's a few things we've done already that I want to make sure you understand. Okay, so if I make a variable, do you agree that is making a variable A, which is to be assigned the value 5? Okay. Now if I made a variable B, whoops, is that another variable? Yeah. Okay. And we assign the value 5. But is A B, not equal to, but see, when you assign a variable, it actually assigns a memory address for it. Okay? So I'm just going to run this. Okay? Then we're going to do a few things with that. So I just ran it. So basically, this is the code I typed in. So now over here, if I type A, what should I get? 5. So if I type B, what should I get? Okay. But what if I type A is B? So is A B? Are you sure?
Sure. Yeah.
Because they're both 5. So what happens is, Python's smart enough to say, okay, you're creating a variable A, which really holds 5 in it. Now you need another variable B, which has the same value. Why create another 5? Why not just have A and B point to the same location? Make sense? You can actually type print hex ID A. Oh, I missed a parenthesis. Missed a parenthesis. Hex ID. That'll actually show you the memory address where A is stored. Okay? So we've never done this part before. I figured it would be kind of interesting. So whenever we create this variable A, it's stored somewhere. Where is it actually stored? Right there. So if we do the same thing for B, if they are indeed equal, if they are the same thing, should we get the same address? Yes, we should. Okay? So really what's happening is we have two different variables, but they both have the same value, so we're really just put them in the same place. Okay? It's like, why create a new variable if I'm, it's kind of like, I got a remote control, I want to store it in a box. Okay, I want another box that stores the same remote control. Should I really just make another box, or just say, this box is both A and B? That's what it's doing. It's like, hey, you know what? We already got a box holding a 5. Why not just say this is also known as B? So my name is Ken and Charles. That kind of stuff. You know what I mean? So far, so good? So we haven't looked at that aspect of it before. But that is true. So A and B, at least the way we've done it, are exactly the same. If you call A, you get a 5. If you call B, you get a 5. Doesn't matter. Okay. So if you want to write this code in here, just so you could see the output of it. Oops. I actually put it in my code earlier. I just did it on the screen to show you. You can actually just do this. That way you'll see they're the same. And you can even do a print A is B. That's really what we just did. I did it in the other window. So it prints out true, A is B, and it prints out the address of them. Okay? So far so good. Now what happens if I say A plus equals 1? What happens to A?
It changes.
It changes to what?
6.
6. Okay? So now I'm going to take these same things here and copy them down. So now that A has been changed, what do you think has happened? Are they the same now?
No.
Well, let's find out. So B is in the original location that A and B were both in, but A has been given a new address. Everybody see that?
The address. Yeah, I think it's just because.
See the address changed? A 3 went to a 4.
Does mine have letters in it because it's a different?
Yeah, your address will vary, by the way. think about it. The way a computer works is every time you load a program, it keeps using up more and more memory. So if you have a bunch of programs running, you might be a lot higher in memory. And you're on a Mac, they store things totally different anyway. So I'm assuming nobody has that exact memory address. Correct? You shouldn't. Okay, but you should match here, but it should be different here.
Yeah, why is ours the same?
They're exactly the same? Well, maybe that's the way Mac runs. Maybe Python actually runs in a specific area of memory. Java has what's called a sandbox, where it kind of runs everything inside of this area. Python might have a dedicated space as well. I'm just not sure. So what would happen if I take this, now that we know A and B are no longer at the same address, what if I say B equals 6? Then do it again. What do you think? Are they going to be the same again? Now, I added them differently. I added 1 to 5, and I reassigned B. Now we're the same again. But what happens if I subtract 1 from 5 now? I'm from A. We'll put it back in the original location. So I just copy that code down. Now I subtracted 1. So now B will still be 6. A will now be 5 again. We'll go back to the 730. Let's find out. Yes, it did. Okay? We'll stay that way forever now. I guarantee if I brought up some other programs now, it would just start messing with my address space. But so far, so good. You see what I'm talking about? You see that the A and the B are really names pointing to these addresses. If you work with assembly language, guess what? You work with this. You could use some very short 3-digit mnemonics, but it's nothing as easy. See, these higher level languages, C, C++, Visual Basic, all those, Java, Python, they're high level. We don't have to understand how they work. We don't need to know this address. But it does have one. Okay? All right. So we realize, now we'll do one more thing. What if I say C equals, what are they equal to now? Let's do them equal to 5. Okay? So I did C is equal to 5, and I'm going to change this up just because currently A is 5, isn't it? So is A and C equal? What do you think? Is A and C equal? Yes, it is. It basically says, hey, we already got a 5, so why not assign C to it? So in other words, we can have unlimited names. Yes, ma'am.
I'm confused why it's an A minus, like,
Okay, what I did was up here I originally said A is 5. Then here I just said add 1 to it. Plus equals is the same as saying A is equal to A plus 1. So A became 6 in this case. Then down here I said A minus equals 1. That's the same as saying A is equal to A minus 1. It's called a compound operator. It's a shortcut way of writing it. I could have done, let me comment this out, A equals to A minus 1. It's just a lot shorter to write this. And after you do it a lot, trust me, you're never going to write this again, if at all possible. I would have loved been able to do this. Oops. You can do that in Java. You can do it in many languages. You just can't in Python. Nope, can't do that. Why? Maybe someday they will. Someday they will. It's just different ways of saying the same thing. Okay? All right. So now we got our strings pretty much all figured out. So everybody understand what I'm saying, this whole address thing. Just because we have an A and a B, if they're both equal to 5, they're still pointing to the same location in memory. And now you saw that if I increase A, it actually gets moved to a new location because the old location had 5 in it, which B is still using. And, so A had to get a new place. We couldn't just get rid of the 5 because B was still using it. If we had actually changed both of them, yes, it could have stayed at the same location. Now, let's do this. A equals that. Now, what's the difference between what I wrote above and what I just wrote there? Not a string. A list. So up above, I just said A equals 5. A is equal to the integer 5. So the value 5 was stored at that address. Now I'm saying A is equal to a list. And a list is a collection of items. So if I do B equals 5. Now if I say, is A and B the same, what am I going to get? They did before. They were equal before. Remember that? Remember at the very top, this is the first thing we did. A and B were equal. They're both signed 5. See right there? It's the first thing we did.
False.
Now it's false. But did I not just assign 5 to both of them? Now when I do it, it's like, no. And look at the difference in memory. I mean, a very big difference. Because what we're saying is, a 5 is what's known a constant. A 5 is a 5 today. 5 will be 5 tomorrow. And it'll literally be 5 forever. 5 can never change. Because if you add 1 to it, really 5 is still there. But now you also have a 6. See what I'm saying? There's still a value of 5. That's a constant that will never change. List, on the other hand, always change. Always change. So they're stored in it. So really what we were seeing up here is the constant location of a 5. Okay? Down here, we're pointing to where our list is going to be stored. We're no longer pointing to a remote. Now we're pointing to a place where we can store a bunch of remotes. Okay? All right. So we did that. We'll see they're no longer the same. Now, what if I do this? So we have A and B. What if I say A equals 5, 6? Okay. Now, I want to print out. I didn't try this before. I'm going to try this. I don't know what's going to happen exactly. Print hex ID A0. In theory, it should be that 730 address. See if I'm right. Okay. Yes, it is. Y'all see that? What I said was A, the list A. Actually, let's print out both of those. So I'm going to print out, and copy this one 3 times. So first thing I'm going to do is print out A. Then I'll print out A0 and A1. So it's going to print out the address of the list, then the address of the first element in the list, and the second element in the list. Everybody with me? Okay. So these are my 3 I got right here. Yep, right there. And it basically said that this address here is A. That's where my list is stored. And the first element in the list is stored at this 730. Ends in 730. And the second element is stored at 740. Why are they the same numbers as what we saw up here? Anybody know why?
Because A is that number and B is that other number.
Right. A is a constant. A is never going to change. A is assigned somewhere. So this list is now pointing to where the 5 is stored at. Remember A5 was stored here. There was 5, there was 5, there was 5, there was 5, and there's 5 again. 6 was stored here, and here, and here, and now here. Really, 6 didn't change. It's a constant. 5 didn't change. But the way the list is accessing it is changing. Okay? All right. So now we did that, but I'm going to, right here, and add a code. B is equal to A. Okay? Now, let's print out, I'm just deleting this. Print A is B. What do you think? Is A equal to B? Is A B, in other words? Wasn't it the same before? Remember when we did it up top? Remember right at the very beginning we said A is B, and what did we get? We got true. Then we got the address of A and B. They were the same, remember? This code right here is this result right here. So the only difference we got now is now we're saying A is this and B is now equal to A. We'll see what we get for output. We're getting true in the same address. Why is that? I thought when we did this list right here, see this here? That is this one right here. We got false.
Because we set it equal to A, not to the same thing as A.
I think you're right. Down here we said B is equal to A. Up here we said B is a new list containing a 5. See the difference? This says create me a list containing the number 5. This says create me another list containing the number 5. Two separate lists. Just happen to have the same thing in it. This one says create me a list with 5, 6 in it and make B point to it. If we actually look at our book, there's actually a picture somewhere in here. Maybe. There it is. So we make banana, banana. We can actually make them so they point to the same element. It's called string pooling. Especially in Java, you have to use equality to check strings. You have to use the dot equals method. Well, your compiler's smart enough to know that, hey, you know what? If you're storing the word banana, do I really need to store the banana twice? Why not just store it once? And then it makes things point to it. It's like, I realize A and B are separate bananas, but we really only need one banana. So we really, without you knowing it, even they just puts it in one place. Good idea or bad idea? I think it's a good idea. We're saving memory. Has anyone seen Apollo 13 with Tom Hanks? One person.
Yeah.
You seen it? Okay. They broke down in space, and they had to start up. It was the Apollo 13 space shuttle. But they were, I forget exactly what was wrong, but they had to start it up without using more wattage. Was it watts they were looking for? Watts? They couldn't go over a certain amount or it would crash the system. So they had to figure out ways to start the lunar module up without using a lot of memory. So wouldn't this use less memory? I mean, I realize here storing the word banana is not a lot. But banana is made up of 8 bits. So if I'm going to have, how many? We got 1, 2, 3, 4. We have 6 letters. Each letter is sort of 8 bits. So what's 256 times 8? No, 6 times 256. So 6 times 256. That's 1.5 meg to store the word banana. Technically, it's larger than that because the variables could actually hold more than 256. But, so if we were storing, 15 bits for banana, and again another 1500 for the next banana, why not just store it in one? We just saved half our memory. And it's things like that, decisions like that, the compilers, that's how you can tell a good one from a bad one. Because if you keep storing the word banana and it keeps taking up more memory, it's crazy. Why do that when you already have it? Okay? Think about it at your house. How many of you have measuring cups at your house? Measuring cups.
Oh, yeah.
How many sets of measuring cups do you have?
2.
I got a bunch. Do I need a bunch?
No.
We got the white ones with the round hole in the end. We got the white ones with the square. We got the M&M measure. We got every freaking version of measuring cups you can imagine. Is that wasting storage?
Yes.
Oh my God, yes. We got that one drawer. You all got that one drawer.
Yeah.
You open it up, it's like, what in the... somebody I was watching a video of, they said, what you need to do is drawers like that, take everything out of it, put it in a Tupperware container, and put a date on it. That as you use things out of the Tupperware container, wash them, put them back in the drawer. At the end of 6 months, dump the container in the trash. Because there's stuff in there you ain't used in 5 years. Think about it. You know the things you stick into an orange and then squeeze the orange? 15 years ago you might have used it. It's still in that drawer. So why we have it in the drawer? But it's the same when we're storing variables. Do we really need to store banana twice? No. But when it comes to a list, the list is not just the number 5. It's a collection that can store the number 5. All right. Kind of understand? I know a few of you are like, what in the hell is he talking about? Okay. Get at least a little bit of this. Nope. Did someone say nope? Oh, okay. They said nope. Chapter 11 does talk about this in great detail. And actually, it's great the way they do it. Please read it over. So I'm just covering little parts of it that I think are kind of, because I know a while back we talked about hex, and one of you is like, what the heck is hex? Remember I tried to install Wireshark? Do we still have the bear on here? Sure enough, Phil's got that darn bear. So I can't install it, so I can't show you. But no, they are removing. But hex is the way everything is stored, and it's an easy way for us to see where things are located. Okay, let's look at this next one. I'm going to take this code right here. A is 1, 2, 3. I'm going to get rid of these in the front. Okay, print. Oops. And I got true. The very last line, true. Because what we did was, again, we made a list. Now you notice this list is different from this list. Okay? And really all A does is points to the beginning of the list. Okay? Now actually I want to see actually where A is stored and where B is stored again. Alright. So this piece of code right here is this piece of code right here. Okay? You can see B is equal to A and they're stored at the same location. Now, I ran this next piece of code. You'll see A is now larger, but it is a new list. Okay? You see it becomes a new location. Now, there's also something we talked about at one point. We talked about how strings are non-immutable. Anyone remember that? It was a few weeks ago. If I make a string, okay, do y'all agree that's a string? Can I print out, like, print name 0? Can I do that? And what should I get? Anybody know what I should get? The K. I should get a K. I did. I got a K. What we did is we told it to create a string. A string, isn't it basically like a list of letters? Or an array of letters? But I said, okay, we have a string. We're going to call it Ken. My name Ken. We're going to print out the first letter. Now I'm going to go in here, and I want to change the first letter. I'm going to say name 0 equals B. I'm going to print out. Now, should I not get Ben? Why not? Whoa! Can't do that. Strings are non-immutable. In other words, once you have a string, you can't just change it. You can create a new string. Now, I could literally say name is equal to Ben, no problem. I can even say name is equal to B plus the rest of name. Remember that? We did that a couple weeks ago? Okay. So I can overwrite the string. But when we do the same thing with lists, let's create how am I going to do this? We're going to make a list, and it's going to be made up of 3 letters. Oops, get rid of the M. Now we have a list. Will it work now? Natalie's like, I don't know.
Wait, no.
Why not? Let's see what it does. I changed it. Whoa, it worked fine. Because what I did was, rather than name being equal to the string Ken, I said name is now a list, no longer a string, even though they function the same. So when I printed out 0, I still got K. But now I can actually go into a list and change it. So the only difference was a second ago, this is how it was. That's how it was. But now since I've had list, which is made up of 3 characters, we're fine. Let me show you again. So if I get rid of that one, so I'm using the first one, it should not work. And it does not. But if I get rid of the first one and use the second one, it works. So it's kind of weird, and the reason I bring this one up is I've actually had a problem that took me nearly an hour to fix. So I said, why can't I change it? What do you mean it's not immutable? Why? Because I didn't define it correctly. I defined it as a string rather than a list. I'm like, well, that's stupid. Okay. I'm going to try the third way. I do not know if this is going to work. Actually, it'll work. But what am I going to get when I print name 0? Anybody? Don't run it first. What's the last thing that's going to be printed? Is it going to be Ben? Or is it going to be B? I think it's going to be B. Sure enough, it's B. Okay. How about now? Am I going to get Ben or am I going to get immutable error again? I think we're going to get immutable error. Maybe not, but yeah, we did. Okay, good. That's what I thought. Because name 0 is equal to the entire string, and when I said change the list first element, which is Ken, first character, which is K, I can't because the list is this. But without this, it works fine. What?
Oh, I get it now.
You get it? Seriously. It's kind of a... It's one of those points that you're not going to remember until you're going to be like me working on a project for an hour and say, what are you talking about? Then you're like, oh, stupid. Yep, now it's B. Okay. And what we could have done if we wanted to keep the original string, we could have said, if we get rid of this guy, hold on. See if we do that, now we have Ben instead of Ken, correct? Now we have B. But we still have the rest of it. If I print out the whole string, now I'll get Ben. Yeah, I get the whole name, Ben. So, okay.
Can you do the 0 colon?
Yeah, I could have got 0 colon to overwrite a portion of then the rest of it, yes. And you could actually have used that with a string that way. What we could have done, we could print out, rather than this line here, we could have said name equals to name 0, 0 plus name 1 colon, correct? Is that right? No, name 0 1 colon. I think that'll do it. Hold on, let's see. Darn, I still got B.
You changed the first thing to...
Because that's the B, plus, but isn't this...
Shouldn't you just erase one of those zeros on the left one? Since name 0 equals B.
Okay, let's try that. My brain's not... no. Can't be a string. Because this one here, remember we're working with this guy right here. Name 0 is Ken. So we're saying name is equal to Ken. But we've already... oh, that's right. We got to get rid of this line. That's why. That's why we got to get rid of this guy. So now if we say name equals... that's what we need to do. B plus name 0, 1 colon. That'll do it. Yes, that did it. That's I just had that in there wrong. So. Somebody following along with me? Okay. I know a few of you are answering, so you kind of got a clue what's happening. Will you ever need to do this in this class on a test? No. But I'm trying to give you some stuff that when you're trying to work on an assignment, the last couple assignments are not going to be as simple. Because that's crazy. And you guys can literally solve it in 15 seconds. That's kind of... Okay. So far, so good? All right. So we kind of talked about that already. We can clone lists as well. Let's look at what their code says here. By the way, today, just submit something we did in here. So I know you did something. But that doesn't mean stop following along and play Minecraft or anything. What? Screenshot, please. It's just so much quicker. See, the problem is, when you all submit a Python script and I click on it, it runs it in Python. It goes away. I'm like, I didn't see what you did. So what I have to do is I have to save it. I have to open it up in idle. Now, I do have a folder for each one of you, but that's like 5 extra steps. I mean, yeah, but when I grade what? 200 assignments a week? Easy. So that adds up. So, all right. So let's see what they're doing. They're kind of doing what we just talked about. Okay. So what should we get here at the end? We get 1, 2, 3. So what they did was they said A is 1, 2, 3. B is basically a clone of A. It's the same thing as saying B is equal to A. But this way we got the entire list.
Why do it though, if you could just do B is equal to A?
What if you don't want the whole list? You could have done one clone. We could have... Oh, where'd my code go? Lost my code. We could have said 1 colon, and now we're going to get 2 and 3.
Yeah.
It's just different ways. It's a slice is what it is. So...
1:3 would just get you 2.
What now?
1:3 would just get you 2.
I don't know. Let's try that one. Where'd my code go? Someone stole it. There it is. 1:2 should have given me... Yeah, should have given me just 2. Yep, just 2. Very good.
But why not just put B equal A?
What if you don't want the whole thing? Yeah, it's... So like I'm writing a JavaScript downstairs to create substitution rules for John the Ripper. And I originally wrote it where I just called it substitution. And I substituted one letter. But then I says, what if I want to substitute 2 letters? So then I made sub 1 or sub 2. And I said, wait a minute, I can actually... Just calling like B is equal to A is just very generic. What if you don't always want that? If you learn to do it this way, it'll always work for whether if you want just all of it or one part of it or the whole, So it's just a little more detailed. Okay. Down here, so now that we have our list, actually let me get back to what we had. Now we know B is equal to 1 through 3. Correct? So now what if I say is B 0 equals 5? What do I get? Oops. Well, actually, I can do it here. That's fine. So what is... A is 1, 2, 3, and B is 5, 2, 3. See what I did?
Yeah.
I just wrote it in the wrong window, so... Okay. All right. We can loop through lists. We've done this many times, actually. We did it with colors. We did it with quite a few things. If you want to see it, we'll just put it in here so you can see it. So it should print out Joe, Zoe, so on and so forth. Okay. And you could actually even edit this and say, I hate... Actually, I hate Joe. I hate Zoe.
Nice.
Okay. Then that would probably not be the best name for friends. It would probably be...
I always do Brad,
I know. Whoever made this, they just love those. They have Zuki this time, though. Did they have Zuki? They might have Zuki before.
I think we've had Zuki before.
All right. Then they actually took the same thing down here. I like to eat, and they replaced it with fruit. So you could very easily replace portions of it. Okay. All right. What does this do? Someone tell me. For numbers in range 20, if number %3, what's it checking?
If it's divisible by 3.
Right. Modulus 3. If it's divisible by 3, it's going to print out. Let's see what it prints out. Where'd my code go? Get them just. Okay, 0, 3, 6, 9, 12, 15, and 18. Okay. Nice. All right. Let's see what else they got in here. Oh, here's one. Yeah, this one's kind of different. Let's look at this one. Explain what it does here. This one here says, I'm going to actually edit it just a hair. Print XSI. Okay, so we have a list, 1, 2, 3, 4, 5. Then it says for I in range length of SX. So what is the length of SX? 5. I like that. 5. So for I, what are the values going to be for I then? What's it going to start with? 0, 1, 2, 3, 4. So this says XS0 is equal to what's currently in there, which in case the first time would be 1, power of 2. So the second time it runs through would be a 2. So it says XS1, which is the number 2, is equal to the value of XSI, which is 2, raised to the power of 2. So so the 2 becomes a 4.
So 1, 4, 9, 16, 25.
Yep. Should just duplicate all of them. There it is. 1, 4, 9, 16, and 25. All it did was it overwrote the element with the value raised to the second, second exponent. Then I just printed it out so we can see what the value was. Okay. All right, we could also do enumerate. It says generate pairs. Let's try that one. Again, you don't need to submit a picture of all this, just something we're doing today. I just added on here that way. Hey, we did that 3 days ago. What was that? Let's see what that one does. Print XSI. Okay. So when we run this one, we get 1, 4, 9, 16, 25. We get the same thing. But the way this works, it actually goes through and keeps track of the index plus the value. So this one here has an index of what? 0, value of 1. And this is index 1, value 2, index 2, value 3. So we can separate them out. So we can do XS equals value. So it's a little different to do it. It takes the list with enumerate and breaks it into 2 pieces for us, which is kind of nice if you want the value or the index. Okay? So far, so good? All right. So they just walked through there. They just printed out the index and the value. List parameters, I think. Let's see. Yeah, this is this module. We're not going to walk through that. I don't feel like typing that one in. Methods. You can append to a list very easily. You can use .append. Okay. You can also insert. At where? So if I say insert, say I have a list that is 5, 27, 3, and 12, and I say insert at position 1, the number 12. What happens to this initial list?
12, 27.
Yeah. It takes the 12 and puts it where the 27 is, but it doesn't overwrite 27. It inserts it. So that's why you end up with the 27 getting moved over one position. Whereas over here, when we did the, where'd it go? The append. Did I pass it? Oh, there. Append appends it to the end. Insert inserts it in the middle. Okay? You can also extend it. Puts whole list onto the end of it. So you can take this entire list onto the end of the prior list. You can also reverse it. We've done that. We've done sort too. Didn't we do sort? Or not in this class? We've done sort. If not, you can sort it. I thought we had. We haven't?
I feel like we've done it before.
We did it somewhere.
Yeah.
I don't know.
Well, we're going to do it now. Fine. We're gonna sort it.
I don't
Okay.
remember doing that.
All right. So in this example here, what did we end up with? We ended up with, they're already sorted. That sucks. So we're going to unsort them real quick. Do you all agree they're no longer sorted? They are no longer sorted. But I could say print, let's go to the end here, now that we're done, print xs.sort. So it's going to print it out, then it's going to print it out sorted. So it printed it out the first time, and then it printed it out sorted, but somehow I got the word none in there. 5, so we ended up with 25 the first time, then we ended up with 194. Something didn't work. What didn't work? Come on. I know that's how you do it. The list is XS.
What the heck?
Okay, let me try printing it out doing it separately.
Built-in method sort of list. What is it?
It should be sorted. There, it's sorted this time. That was weird. I don't know why. It's sort of fine that way. Yeah, I've used sort quite a bit. It's kind of nice to have this because like Java initially didn't have a sort function built in, and now they do. There's just a lot of different languages where you cannot always do that. Okay? You can also reverse it. That changes its order. You can also remove items. You can say, get rid of item 12. Maybe you're searching through it, and if it finds it, remove it. Think about it. Maybe we got a list of available hotel rooms. So we search for one, and once we clean it, we click on that one, and it removes it. Okay. I watched, there's a show on Netflix, The Most Outrageous Hotels. Anyone ever seen that? It was a hotel in Singapore that has two huge, I'm going to show you a picture. You guys see this. I was totally shocked. Show me the darn picture. Where is the picture? Seriously? There it is. Look at that guy. Well, if I can. That's a swimming pool on top. Yeah. It's like, wow. But, man, it was all this stuff. There's so many rooms. There's like so many, like 2,800 people that work there. And it's like, wow, it's a crazy hotel. But imagine if you had a list of rooms to clean. You could literally search for a room that needed to be cleaned, and when you clean it, you could use the remove function to remove from your list of rooms to be cleaned. That kind of stuff. You could even sort it, you know, based on what number you want. So a lot of different functions you can use on it. So now they're showing us stuff we can use. I can use append inside of our method, but we're not going to write that method. You can also create lists, because we know we can only return a single item, but a list is a single item, so we can make a list or a tuple. Remember tuples? Then when we can return. Now, if we're returning everything that's the same data type, would you rather have a tuple or a list? List. I mean, why not? If they're different types, then I'd go with a tuple. All right. We kind of already talked about the difference between strings and lists, but there is a function here called split. I don't know if we've used it yet. I use that a bunch in my program, so we'll say song. Well, I'm not going to do a song. It's stupid. Name equals. So there you go. I got my name. Then I'm going to say individual equals name dot split. Then print individual. What should I be getting? What do you think? Should I get a list of 3 items? The answer is yes. There you go. I took my full name all in one variable and I split it on the spaces and made a list out of it. With split you can specify split on commas, split on colons, split on whatever. Default is to split on spaces. Here's an example. You can actually even split on AI. Let's split on, what do I have a lot of them? Let's split on E's. I have a lot of E's. Split on E's. So I should end up with K, then a bunch of other weird ones. So I got K, then I got NN, then TH, then, yeah, that's just weird. But split's very handy. I use it for all kinds of things, especially when I want to return a lot of stuff. I'll return it like with colons between it all, and then I can just split it out individually at that point. You can also join. That puts them together. And you don't have to specify something to put in the middle, but you could if you wanted to. Okay? We've done range.
Split on the letter?
What?
Split on the letter?
Yeah, split on the letter. Split on the E.
How did you do that?
Oh. It says split on E. Okay. Now the thing is, it removes the E. Because normally you're going to split it on like a colon or something. You don't want the colon, but you want the data elements that, between all the colons. Okay? A student was giving me a hard time about my John the Ripper script not being finished. I'm like, dude, I got to teach other classes, and I don't need it till halfway through the next semester. So maybe I'll go finish it this weekend. All right, so we can join with that. That's kind of the opposite. Instead of splitting it, you're joining it. Let's see. I think that's... Oh, we already did this. Yeah, we did tuples with lists inside of a list, didn't we? Yeah, we did that. Oh, matrices. We're not going there in this class, sorry. That gets too confusing. I should do that in another class. So, all right, I think that's all we're covering today. The big part of today I wanted you to get out of all this was that whole thing we did initially where you saw the addressing of variables and the addressing of lists. Because sometimes it is important to know the address of something. Okay? So you can get out of here 15 minutes early.
Screenshot of the code?
Yeah, just screenshot of something we did. Either the output or the code is fine. Just so I know you're paying attention at least a little bit. Alright.
Oh, my screenshot's a little janky.
That's alright. As long as it's actually a screenshot.
Also,